Okay. We saw an example when we were talking about intervals of increase and decrease, where we had a function that was shaped kind of like a bird or like a open book, and we said that here this function is decreasing, then it suddenly switches to increasing, and right at the point here, our first derivative became undefined because the function was vertical for just a second. And we said that this point could still be considered a local minimum as long as f of x was defined there. We said we decided we're willing to forgive the first derivative going undefined for just an instant, and that doesn't disqualify this point from being a local minimum. Now, what we're seeing in this example is an analogy to that with the second derivative, where this function is clearly concave up all along its left half. All of this is concave up. And then it transitions to concave down for its right half. And so we're interested in the point right in the middle, thinking that might be a point of point of inflection, sorry. But let's see what happens to the derivative. If f of x is the cube root of x, meaning f of x is x to the 1/3, then the first derivative is 1/3 x to the minus 2/3, and the second derivative is minus 2/3 minus 2/9 x to the minus 5/3, which means minus 2 over 9, and then this is in the denominator because it has a negative power, and it's the cube root of x to the 5th. Now when we look at our second derivative, if we put 0 into it, we get 0 to the 5th power is 0. Cube root of 0 is 0. Times 9 is 0. Negative 2 divided by 0 is, kaboom, undefined. But just like we said, this point over here could still be a local minimum, even though the first derivative was undefined for a second. Here, this point can still be considered an inflection. I'll put POI for point of inflection, even though the second derivative goes undefined for an instant. We still have our change from concave up to concave down. The function is defined there because the cube root of 0 is just 0, and so that point counts as a POI. In previous examples, I've already been saying that when you look for interesting values on the second derivative, you should look for places where it's 0 or where it's undefined. This is why, because those undefined points can still be inflections. They're still interesting to find. So remember, when you're doing a second derivative or a first derivative, setting up a sign table, look for places where it's 0, look for places where it's undefined. They're both worth investigating.